Welcome to The Explainer. I am absolutely thrilled to have you here today, mostly because we're tackling something that happens literally millions of times a day, yet somehow remains a total mystery to most people. I mean, think about the last time you bought something. You swipe a card, you hear a little beep, and you walk away with your coffee or your groceries, whatever it is. It feels incredibly simple, right? But behind that simple piece of plastic, or, the virtual card on your phone, there is an incredibly complex, lightning-fast data dance happening behind the scenes. So today, we are entirely focused on demystifying the issuing authorizations lifecycle and really breaking down exactly how you, as a developer or a platform, can control this entire process. So, I want you to really think about this question for a second. What actually happens in the 2 seconds after a card is swiped? 2 seconds. That is literally the blink of an eye, but in the world of payment issuing, it's an absolute eternity where decisions are made, funds are checked, and rules are applied. If you want to build a powerful commercial card program, you absolutely need to understand every single microsecond of this window.
Okay, let's dive into this. Here is our roadmap for today. Number 1, the anatomy of a swipe. Number 2, managing real-time webhooks. Number 3, navigating complex authorization types. And finally, number 4, understanding authorization outcomes.
Let's start with part 1, anatomy of a swipe, focusing on the standard path. We're going to map out the exact sequence of events that triggers when a cardholder attempts a standard purchase. Think of this whole process as a very, very fast-paced conversation. Step 1, as soon as that swipe happens, Stripe immediately steps in and checks that the balance used for issuing actually has sufficient funds. They'd also check that the card is active and that any predefined spending controls you set up actually allow this specific authorization. If everything looks good there, we move right along to step 2. Stripe sends an issuing authorization.request event directly to your server. And this brings us to step 3, which is really your moment to shine. Your real-time authorization webhook receives this request, and your system decides programmatically whether to approve or decline it. Finally, step 4, Stripe sends an issuing authorization.created event, formally notifying you of the authorization creation and whatever the final decision was. Now, let's look at the immediate financial impact of your webhook's decision, because this is huge. If you approve the authorization, the authorized amount is immediately deducted from your issuing balance. It's essentially held in reserve, and it stays there until the authorization is either fully captured by the merchant, voided, or it simply expires without capture. But if you decline the authorization, the status is immediately set to closed. And the really beautiful thing here is that no financial holds are placed on your balance at all. And this brilliantly illustrates the life cycle of an approved authorization. Just look at how an authorization ultimately reaches its end state. If it's approved and fully captured by the merchant, boom, the status becomes closed. If it's fully reversed, the status changes to reversed, completely undoing that initial balance impact. Now, if Stripe expires the hold after a period of time, the status becomes expired, which again returns those funds right back to your available balance. But notice that last row. If it's approved and only partially captured, the authorization actually remains in a pending status, essentially waiting around to see what happens to the rest of those held funds. Moving right along to part 2, managing real-time webhooks, otherwise known as the ticking clock. So while having programmatic control over every single swipe is amazing, it comes with a very, very strict constraint: exactly 2 seconds. When Stripe sends that issuing authorization.request over your webhook, your server has to process the data, run whatever complex internal business logic you have, and send back an approve or decline response, all within this tiny 2-second window. If you take too long and miss this window, Stripe just steps in. They automatically default to your predefined webhook timeout settings from your dashboard to either approve or decline the authorization for you. Trust me, you do not want to be missing this window. However, there are actually a few scenarios where that 2-second window doesn't even apply, and you won't even get that initial request event in the first place. For instance, if a card is inactive, or a swipe just outright fails your predefined spending controls, Stripe will auto-decline it instantly. No webhook needed. Conversely, if you don't even have a real-time authorization webhook configured at all, and there's no obvious reason to decline the charge, Stripe will just auto-approve it. Finally, if a business sends a real-time authorization request for a refund, well, Stripe already has default logic in place to process those without needing your 2-second approval. You're just going to see the refund transaction object pop up later. Which brings us to part 3, navigating complex authorization types, or, as I like to call it, the edge cases. So far, we've basically been talking about the happy path, right? Buying a coffee for a fixed, known amount. But the real world is messy, and we have to handle those edge cases. Let's start with partial authorizations. This is when you approve a specific, lower amount than the merchant originally requested. This is incredibly useful when a user's account has insufficient funds to cover the entire purchase, but you still want to let them spend whatever they do have left. But here's the catch. For this to work, you absolutely need to look out for the is_amount controllable field in the authorization request. If that field is set to true, you are free to respond with a lower approved amount. To really ground this abstract API concept in physical reality, let's look at a scenario we all know pretty well: getting gas. Fuel dispensers in the US actually use partial authorizations. Think about it. When you swipe your card at the pump, an authorization request for just $1 is sent. It's essentially just a quick status check. But because the pump obviously has no idea if you're going to buy $10 or $80 worth of gas, a default hold of $100 is placed on the account. Then, when you finish pumping, an issuing authorization.updated event arrives to reflect the actual purchase amount, and the hold is adjusted. It's a really perfect example of a complex authorization happening in everyday life. Then we have incremental authorizations. Contrast to standard authorization, like again, buying that coffee for a fixed amount, with staying at a hotel. When you check in, the hotel authorizes a certain amount for the room. But what happens if you order room service later? They definitely don't want to run your card for a brand new, completely separate charge. Instead, they send an incremental authorization. So Stripe will send you a new request event for the original authorization, but with an updated pending request.amount. Your original authorization remains safely approved, while you get to decide whether to approve this new incremental addition. And just to really complete your mental math of the whole system here, there are a few more specialty scenarios you're going to encounter. Partial reversals happen when a merchant decides to actually lower the authorized amount, which immediately releases those surplus funds right back to your available balance. Then you've got card verifications. These are those zero amount requests you see when you sign up for a free trial. They literally just check if the card is valid without moving any funds. And what about multi-currency purchases? Well, the card network just automatically converts the local purchase amount into your card's currency using the network's daily rate and holds the funds appropriately. Simple as that. All right, final section, part 4, understanding authorization outcomes and exactly why things fail. As developers and program managers, you know you spend a ton of time troubleshooting, and thankfully, the Stripe API gives you some incredible diagnostic clarity here. When an authorization is approved or declined, you can just look at the request_history.reason field to see exactly what went down. Here are a few common examples. If you see spending controls, you know for sure your own rules blocked it. Suspected fraud means Stripe's internal risk control stepped in. Webhook_timeout tells you exactly what we warned about earlier. Your server took longer than 2 seconds. And insufficient funds just means your issuing balance was simply too low. Honestly, this enum data is going to be your absolute best friend for debugging. But, okay, I do have to share a slightly frustrating reality of the payment ecosystem, which is perfectly captured in this quote straight from the source docs. In some cases, an authorization might be declined and neither you or your connected accounts will receive a webhook event or an authorization record. We call these ghost transactions. Basically, the decline happens way upstream at the terminal or network level before any information is ever even transmitted to Stripe in the first place. So the absolutely crucial point here is that when these invisible declines happen, you need to be prepared before you go running to Stripe support asking for help. Because Stripe has literally no API record of it, you have to provide the breadcrumbs. Always collect this rapid-fire tech list. First, you need the exact time of the decline. Second, the card holder involved. Third, the specific card used. Fourth, the merchant involved. And fifth, any other surrounding circumstances you can gather. Armed with this data, support can actually help you investigate what happened upstream. So we've covered a lot of ground today. We went through the standard swipe, the stress of that ticking 2-second webhook, the real-world complexities of fuel pumps and hotel holds, and exactly how to figure out why a transaction failed. So I'll just leave you with this final thought to consider. Are you ready to take programmatic control over every swipe, hold, and capture in those crucial 2 seconds? The issuing authorizations lifecycle is definitely complex, yes, but with these tools, the entire process is completely in your hands. Thank you so much for joining me for this explainer, and happy building!